Welcome back guys. So I am with this setup again, and this is I guess after 2 long years. So I am feeling nostalgic, and at this moment I want some support from you guys. So because I was not uploading regular videos in this channel, so I can see that the reach of the channel is almost dead. So what I want from you is that share videos in different platforms and comment down in each video and give likes so that again I can regain the reaches. Okay, so I want that from you, and I can promise you that I will make regular videos from now on, at least once a week, I can promise you. And if I get more time, I will make more videos for you. So without further delay, let's start our today's topic. So you can see this is our question. So in this question you are given with this di-ester compound, and it is treated with sodium hydroxide and water, and 4 options are given. So what will be the correct product? So it is very simple reaction at a first glance, that ester group is there and sodium hydroxide is given, so ester hydrolysis will take place. But you can see in the options you have diacid here, you have monoacid here, and you have diacid here. But in this case ring expansion has taken place. In this case this position is open, here the position is intact, here the position is intact. So what will be the product? We will discuss that. So let me first erase all these things and concentrate to the question. Okay, so in our question we have this thing. Okay, now whenever you get a cyclohexane compound or a derivative of cyclohexane, you must draw it in the proper chair form, otherwise you cannot tell what will be the pathway or what will be the direction of the reaction. So if I draw this in the chair form, how it will look like? Okay, so let me first draw it. Yeah, so I am drawing it in slightly tilted manner. So this is the cyclohexane part. This is the cyclohexane part. Now these two hydrogens, you can see these two hydrogens are facing above the plane, so I am making it above the plane. Okay, so one is axial, another is equatorial. That's how you can make both of them above the plane. Now there is a 3-membered ring. So the 3-membered ring I can draw like this. Okay, so this is our 3-membered. I can extend this hydrogen like this. Okay, so this is now a 3-membered ring, and on this 3-membered ring you have one ester group over here and another ester group over here. Okay, so these are the 2 ester groups. Now in order to hydrolyze this ester, the OH minus of the sodium hydroxide, it has to attack on the carbonyl carbon atom. So for this carbonyl carbon atom it has to attack here, for this carbonyl carbon atom it has to attack over here. Now you can see this position is actually sterically quite hindered because you have a large ring over there. Okay, so whenever this OH tries to attack over this carbonyl carbon atom, it will be sterically hindered. Okay, so this attack is less favorable. And the attack will take place only over here. So from that what we will get? So from that we will get something like this. So here we have this O minus, we have this OH, and we have this OMe, right? Or in this case OET. So it is ethyl ester, so OET, and here it is as it is intact, OET. So it is intact. Okay, so this is the intermediate, this is our intermediate. And in the next step what will happen? In the next step the tetrahedral intermediate will collapse. So the tetrahedral intermediate will collapse and you will get this thing, right? So you will get acid, and actually it is taking place in basic medium, so you will get carboxylate group over here, anion, and here you have this ester group, OET intact, CO2 intact. Okay, so this is the thing you will get. Now think about the case where the OH will attack on here. Okay, so you will get some intermediate where this position will be like this, O minus, and here OH. So if this OH would attack on this position, you would get this intermediate, right? and this is step 1 and this is step 2, and step 1 is actually rate determining step. So this attack on this carbonyl carbon atom is actually the rate determining step, and this other step, the collapse of the tetrahedral intermediate, is actually very fast, and that is not RDS. So this step will determine the fate of the reaction, and you can see when the attack take place over this carbonyl carbon atom, this intermediate is actually very much unstable. Why? Because here you have 4 atoms on this carbon, this OH, this O minus and OET, whereas in the initial starting material you have only 3 atoms, OET, O and this carbon, right? So only 3 carbon, only 3 atoms. Here you have 4 atoms. Actually on this carbon you have 3 atoms, and on this carbon you have 2 atoms. So from here to here you are going to a sterically hindered substrate or sterically hindered intermediate, which is less favorable, right? So that's why attack will not take place on this, but here the position is quite free. So the ring is this side and this position is quite free, so this position can be easily attacked, okay, and that's why you get this product. So our correct answer would be, so this is our product. Here only one group will be hydrolyzed. So the group which is above the plane would be hydrolyzed, COOH, and here you have CO2ET. So selective hydrolysis, selective ester hydrolysis will occur. So these two positions, they are regioselectively different. So this is a regioselective ester hydrolysis, and I hope this video will help you to understand the regioselectivity in this type of reactions, where at first glance you may see these two positions are almost equal, but if you look in deeper way, you can see the difference, okay. So I hope that this video will help you. If you find this video helpful, give a like and share this video with your friends, and thank you for watching.